Start this video by talking about something called arc measure. And so we spent the last video really talking about what arcs are and how do we name arcs, and so now we're really getting into how can we use what we know about arcs to find out how long they are. So for example, if I wanted to take this circle on the right hand side, this circle S, okay, which has an arc QRT, okay, we can like let's say we wanted to kind of go around the perimeter and we wanted to put some trim on it, or maybe we just wanted to put trim on a little section of it, like that minor arc RT there. How could we measure how long that little piece is going to be? Okay, so before we get into actually measuring how long that is, we have to talk about a concept called arc measure. Okay, so here's what arc measure is. If I were to ask you to measure the arc of a circle, we are going to measure that in terms of degrees. So we're basically what we're trying to get at is how many total degrees of the 360 that we could have, right? A whole circle around is 360 degrees. How many of those 360 are being used by this particular arc? And so we have in our definition here in the key concept that the measure of a minor arc is the same as the measure of the central angle that is inside of the circle. So if you again take a look at our little picture here, let me grab my highlighting tool and we'll kind of highlight what that is talking about. Okay, so let's grab this highlighter. All right, so if I were to take a look at this 50-degree angle, remember we said central angle is just an angle whose vertex is at the center of the circle. So I created right here a central angle by drawing a radius line from S to R and from S to T. Okay, so when I did that, okay, we can measure the inside angle, and that's what we did, and we got this 50-degree angle here. So this little angle right here in the center is 50 degrees. Okay, but by doing that, by drawing those two radius lines, we also created a minor arc. And so the minor arc is the arc that is created using the same endpoints, right? So this angle ends at R and it ends at T on the circle, and so if I focus on this little arc between R and T, okay, we're claiming that this arc here, okay, is also 50 degrees, right? So the angle inside and the arc on the outside of that same angle are the same length, okay? And so when we start getting around to major arcs, right, so minor arcs are pretty straightforward. It's the space in between the two ends. Well, the major arc is going to be the exact opposite of that. So if we're saying that the minor arc is 50 degrees, if I decide instead of going directly from R to T and taking the minor arc path, I want to go the long way around the circle and end up at T by going through Q, we're going to say that that is 360 degrees minus the measure of the arcs, right? So again, if this is 50, I still have 310 degrees left over in the rest of the circle, and so if the minor arc from R to T is 50 degrees, the major arc from R to T would have to be 310 degrees, okay? And then just as a fact, we know that a semicircle is exactly half of a circle, so that would be exactly half of 360, so 180 degrees for a semicircle, okay? And so we have this other idea called the Arc Addition Postulate, and this relates to something that we've talked about before, namely the Segment Addition Postulate and the Angle Addition Postulate. So just to remind you about one of those, what we said for the Segment Addition Postulate was, let me grab the right line tool, right? If we have some little line segment, okay, and then continuing from that we have some other line segment, right? If I know that this little piece here is worth 2 and this little piece here is worth 7, that I can add together connected line segments, and that means that the big one is worth 9, right? That's called the segment addition postulate. We can do the same thing for arcs, right? So if I have two what they call adjacent arcs, which means arcs that share an endpoint, right? If I were to come to this picture and say if I go from A to B and I know that measure, and then I go from B to C and I know that measure, well, that means that A to C would just be AB plus BC, right? So that's what this is saying right here. The measure of ABC, which means going from A, ending at C, but traveling through B, that arc is going to be the sum of AB and BC. So it's, again, very similar to something that we've done before, right? So let's take a look at a picture and see if we can figure out some arc measures in this circle O, right? So if they're asking us for arc BC, what is the measure? That's this little piece right here, right? Again, we can say that its central angle is 32 degrees. That's using the same lines, right? If we go from O to C and from O to B, right? That's angle that was created is this one right here. That's where the arrow is pointing. This is 32 degrees, okay? If I go from B to D, right, we can kind of take this idea the other way. I can say that this little piece is 32, so this one's 32. And that means that from B to D is BC plus CD, which it looks like that would be about 90 degrees. Well, not about 90 degrees, exactly 90 degrees in the middle, okay? So now I'm getting ABC, and ABC is a major arc, okay, or a semicircle. So we have to decide which one it is. Again, so if I'm going from A all the way around to C in the direction of B, right, so that's the left-hand side of this shape right here, okay, and it looks like this AC is a diameter, right? The endpoints of ABC are also the endpoints of a diameter. So in this case, this is a semicircle, so I'm going to say 180 degrees, exactly half of 360, and now it's saying minor arc AB, and we're kind of looking at this one and saying, you know what, this one, we don't have a central angle for, so we have to think about this one. Okay? So I'm looking at this and saying this little arc here, AB, is made up of O to B, okay, and O to A. Okay? So I really care about this angle right here between OB and OA. Right? And so we have to figure out how many degrees that angle is, and we can use linear pairs, right? Our good friend linear pairs from back in the day, that if from A to C is got to have 180, and we know that this is 32, this angle would have to be 148 degrees, which means the arc from A to B would also have to be 148 degrees. Okay? So now that we can figure out the measure of an arc, we're going to start talking about how can we figure out how long one of those arcs are, right? Like, so if I wanted to take this little segment from A to B and I wanted to straighten it out and measure it with a ruler, how long is it? Okay, so before we can get to that, we want to actually start talking about the circumference of a circle. So again, this is something that we shouldn't have spent too much time on because you should have seen it before. The circumference of a circle is always pi times the diameter, right? So pi d, and this is the one that I'm going to use. You may also see some people using 2 pi r, right? And that's because 2 radius lines make 1 diameter. So these are just 2 interpretations of the same thing. You can either multiply 2 times the radius, if that's what they give to you, and multiply that by pi, or you can just do pi times diameter. So let's get into a problem or two and see how this might show up. So the very first thing is, if you have never seen leaving your answer in terms of pi, it's very similar to when we leave something in radical form, right? When we did radical form, we said if I had like the square root of 3, which is not a nice number. If you type in the square root of 3, it's like 1.7, and it goes on forever, and we'd have to round eventually, and we don't like rounding, so we just leave it as the square root of 3. But we're going to do the same thing with pi, right? Pi is an infinitely long number. We don't want to have to round it, and so we're just going to leave pi as the symbol for pi, which is just the Greek symbol like that. Okay, so for this particular example, they're asking us to find the circumference of this circle, so I'm going to say that C is equal to pi times diameter. Well, a diameter is 2 radius lines, so if this radius is 7, that means that there's another 7 right here, which means the diameter is worth 14. So I'm going to say C is equal to, I'm going to replace the D with a 14. I am not going to turn this into 3.14. I'm not going to go to a calculator and type it in. I'm literally just going to leave it as pi. So what we mean by in terms of pi is just leave pi in the problem, don't multiply it out, and this is good, right? So I'm going to say this, and then we just want to talk quickly about what the units should be here, because I want to put units on the end. The units for circumference are in this case just inches, right? Not square inches, not cubic inches or anything like that, just inches, and that's because this is actually a perimeter, right? We're finding the perimeter of the circle, and when we find perimeter, it's really just kind of like trying to straighten this out and measure it as a straight line, so it's not a square unit. Okay, so in this example, slightly different. I'm giving you the diameter, right? And I know that this is the measure of the diameter. If I was trying to say that 22 is a radius, I would probably have centered it right here on one of the radius lines. So just when you're trying to interpret your pictures, be careful about that. So this one I'm saying 22 is the diameter. So again, I'm just going to say C is equal to 22 pi feet. Right? Not square feet, just regular old feet. And I'm just going to leave it as 22 pi. I'm not going to multiply it out. That is our final answer. Okay, so now that we can find those, again, that should not have been too shocking or strange. We want to talk about, well, what happens if I don't want to know the whole circumference, but I just want to know how long some little section of the circumference is, and that circumference, remember, is what we call an arc. Right? So here is your fancy looking formula. Again, I have 2 of them. I'm actually going to cross off this first one because it's just repetitive, right? So we're going to say let's focus on the one I'm going to be using pi d, right? So they gave you 2 formulas because again it depends on which circumference formula you use, okay? And so here's the kind of where all of this stuff is coming from. So if I ask you to find the measure of the arc is the number of degrees. And it's the number of degrees out of the whole 360, right? So again, if I were to come over here and say that this is worth 20, I'm actually claiming that arc AB is 20 out of the 360 degrees. And that's what this first term in our arc length formula is really saying. It's saying how many degrees out of the total number of degrees, okay? And then this, if you notice, is just our circumference formula. So I'm really asking you to multiply a fraction, what fraction of the whole times the actual circumference, right? So let's see this in action, okay? Here's my picture. I'm asking you to find the red arc, which for us is this minor arc XY, right? And so I'm going to say XY, the central angle is 90 degrees, which means arc XY is also 90 degrees. So I'm going to say that the arc length is 90 out of 360, and I'm going to multiply that by, if I asked you to just find the circumference of this circle, we'd say pi d. So I'm going to say pi times diameter, which they're telling us all the way across one diameter is 16, right? So if I multiply all this out, okay, I'm going to say this is really 90 over 360. I'm going to try to save myself some calculator work. Is really just 1/4, right? And this is really 16 pi. So 16 pi over 4 is really just going to come out to be 4 pi, right? So again, this is just simplifying fractions, right? If you want to see the little middle step that I did not include, right? Really what I'm doing is I'm multiplying these together, getting 16 pi over 4, and then I'm saying 16 divided by 4 is really just 4 pi, okay? Again, this is a measure of a perimeter, so I'm also going to call this one inches, not square inches or anything fancy like that, okay? Here's your last example, okay? And we're trying to find the measure of this major arc XPY, right? And so again, they're telling us out here that this major arc is 240 degrees of the 360, so I'm going to start by writing that, 240 out of the 360, okay? And I'm going to multiply that by, well, they gave us a radius here. We got to be careful. This is a radius, so that means that the diameter would be double that, which would be 30 pi, okay? So again, I have some simplifying to do. 240 over 360 is a fraction that simplifies very nicely. It looks like they both have a 12 or 120 in them, technically. All right, so I'm going to say that this is 2/3 when I simplify 240 over 360, and that's over 30 pi, okay? And so when you multiply this out, it becomes 60 pi over 3. Okay, 60 pi over 3 is really 20 pi. Okay, and again, these are in centimeters, so centimeters long. And again, really what that's saying is that if I were to take this red line and it was something that I could bend and I could straighten it out and I could put a ruler to it, that if I were to measure it, I would get something a little bit bigger than 60 centimeters long, right? 20 times 3.14 would be like maybe 62 or 63 centimeters. So we're claiming that if we were to bend that out and measure it, that it would be about 62 or 63 centimeters long.